Can a car made entirely from office supplies, just rubber bands, paper clips, and a few scraps of wood, really compete with a professional racing machine? Could our humble creation possibly beat a real race car, even if it's just a remote control version built for speed? That was the big question that sparked our curiosity and set our team on a wild creative journey. We set out to compare a professional remote control car, sleek, powerful, and engineered for performance, to our own pile of everyday office supplies. Could we turn these simple materials into a worthy competitor? Our challenge was clear: build a car from scratch using only what we could find around the office, and see if it could be fast enough to surprise everyone. Could our rubber band-powered car, built with nothing but creativity and determination, stand a chance against high-tech engineering and years of racing expertise? The team gathered, buzzing with excitement and ideas, determined to build the fastest rubber band car ever attempted in our office. We started by sketching out designs, carefully planning a lightweight wooden body, sturdy wheels, and a long, tightly wound rubber band to power our creation. Every detail mattered. The rules were simple but strict: a straight track, 2 cars, and the first one to cross the finish line would be crowned the winner. No second chances. The RC car had the advantage of speed, precision engineering, and advanced electronics. Our car relied on pure creativity, physics, and a bit of trial and error. We knew that every part had to work perfectly together. There was no room for mistakes if we wanted to stand a chance. But for us, this was about more than just winning a race. It was about showing that science, engineering, and innovation are for everyone, no matter your background or resources. You don't need a fancy lab or expensive equipment to experiment and invent. Just a spark of imagination and the willingness to try something new with everyday materials. Our little wooden car, dwarfed by the professional RC car beside it, was finally ready to take on a giant. It was a true David versus Goliath moment. The race was on, and with every turn of the wheels, our engineering adventure and our belief in the power of creativity had just begun. Have you ever wondered how a simple rubber band can actually power a car? It might seem like a small thing, but there's a lot of science packed into that stretchy loop. The secret lies in something called potential energy, specifically, elastic potential energy. When you stretch a rubber band, you're not just pulling on it, you're actually storing energy inside it, like winding up a spring. The more you stretch, the more energy gets packed in, waiting to be released. Let go, and all that stored energy transforms instantly into motion, snapping the band back and sending the car racing forward. To make our car go farther and faster, we decided to tie several rubber bands together, creating a long chain. We attached this chain to the car's axle, so we could wind it up tightly. Each twist of the axle wound the rubber band tighter, packing in more and more energy. But there's a catch. If you wind it too much, the rubber band might snap, or even worse, the car itself could break apart from the force. So, we had to find the perfect balance. Enough energy for speed, but not so much that we'd destroy our homemade racer. It was a careful dance between power and durability. We experimented with different numbers of turns, learning firsthand about the limits of energy storage and how important it is to have a strong, sturdy car body to handle the tension. To make sure our car could handle the stress, we reinforced the frame with popsicle sticks and plenty of hot glue, making it tougher and more resilient. Every single part of the car had to work together to contain and control the powerful burst of energy from the rubber bands, so nothing would break when we let it go. In the end, we weren't just building a toy car, we were engineering a machine designed to harness and unleash serious force, all from a few simple rubber bands. Our first tests were a disaster. The wheels spun, but the car barely moved. The problem? Wheel slippage. Smooth plastic wheels couldn't grip the floor. We needed more friction, like the patterns on the bottom of shoes. Tape didn't work, but rubber bands did. We wrapped rubber bands around the wheels, creating instant rubber tires. The difference was huge. The wheels finally gripped the ground. A simple fix with materials we already had solved a major engineering challenge. Now, our car was ready for a real speed test. With rubber tires, our car shot forward, but it was unstable, swerving and spinning out. The solution? Add weight for stability, but not too much. We taped coins and washers to different spots, finding the best balance low and centered. This lowered the center of gravity and kept the car straight. Each test taught us something new. Test, fail, learn, improve. We reinforced the frame with popsicle sticks to handle the force. Every tweak made our car faster and more stable. We weren't just building a car, we were learning to think like engineers. It was finally race day, the moment we'd all been waiting for. Our homemade rubber band car, crafted from scratch with hours of tinkering and trial and error, was lined up right next to a sleek professional RC car. The tension was real as we placed both cars at the starting line, side by side, ready to see if our DIY creation could stand up to the store-bought champion. We wound the rubber band as tight as we dared, feeling the tension build with every twist. The mechanism was delicate, and we knew that one wrong move could snap the band or ruin our chances. Every adjustment mattered, and we double-checked everything before the big moment. The race began with a burst of excitement. The RC car zipped ahead with its powerful motor, but to our amazement, our homemade car exploded forward, surging ahead for a brief, glorious moment. For a split second, it looked like our hard work might actually pay off. The crowd watched with bated breath, eyes wide as our car took the lead. Cheers erupted as it sped down the track, and we could hardly believe what we were seeing. But then, reality set in. Our car's energy was just a single powerful burst. As the rubber band unwound, it began to slow down. Friction and resistance took over, and the wheels lost momentum. Meanwhile, the RC car's electric motor kept it speeding ahead, never losing pace. It crossed the finish line first, leaving our homemade hero trailing behind. We didn't win the race, but we felt like champions. We had built a car from scratch that actually challenged a professional model, and that was a victory in itself. Along the way, we learned so much about energy, friction, stability, and the importance of every tiny detail. Each test and tweak taught us something new. With a mix of science, creativity, and determination, you can build incredible things. Every idea starts with a sketch, and every invention begins with curiosity. The adventure isn't over. Next time, we'll try a better energy release system, maybe improve the aerodynamics, or experiment with new materials. There's always room to grow and innovate. So stay curious, keep building, and never stop experimenting. Who knows what you'll create next?